Hi everyone, I'm going to go over the lab setup today for your oxygen lab. So first thing I'm going to point out is your ring stand. This is going to be connected to the test tube clamp and our generation bottle. This is going to be where the reaction is going to take place in today's lab. Now the generation bottle has a stopper that contains a thistle tube and a L-shaped hook connected to the hose. So when you have your generation bottle attached to at the base to your test tube clamp so it's sturdy, you'll put the stopper back on the top. You'll pour your reactant through the thistle tube in order for the chemical reaction to take place. Now our goal is to create oxygen gas. So that oxygen gas is going to travel up through our generation bottle, through the hose that's connected to a U-hook. And we're going to take a 1,000 milliliter beaker filled with about 500 to 600 milliliters of water and put the U-hook in our beaker of water. We'll see that gas being produced if bubbles come out of the U-hook. Now, oxygen is lighter than air, and we do want to make sure that we have oxygen traveling through the U-shape, the U-hook and the hose rather than up through the thistle. So once you pour your reactant through the thistle and it goes all the way to the bottom of the generation bottle, you're just going to lightly put your hand on top of the thistle so that the oxygen travels through the hose and not out escaping through the thistle. You're also going to need 3 test tubes filled all the way to the top with water. This is where we're going to collect our oxygen. And we want to make sure that the water stays in the test tube. So when I put them in the beaker, I'm going to take a test tube filled all the way to the top with water, and I'm going to put my thumb over the top of the test tube and invert it so the water doesn't come out, and place it into our beaker of water. We want to make sure that these are completely filled so that the oxygen will travel through the hose and get captured in our test tubes. Then I'll take my U-hook, put it in the beaker, and I'm going to carefully place the test tube through that U-hook. Now, you're also going to need a graduated cylinder filled with 40 milliliters of hydrogen peroxide. What we're going to do today is we're going to break the hydrogen peroxide apart, which hydrogen peroxide, for those of you who don't know, chemical formula is H2O2. When I pour that into our graduated cylinder, I'm going to pour just a little bit through the thistle tube, just so that you see how it pours. And then you'll ask me for the catalyst to speed up the reaction. Our catalyst today is manganese dioxide. What I'll do is I'll come over and I'll open up your thistle tube. I'll pour a little bit of our catalyst into your generation bottle. I'll stopper your generation bottle, and then you can pour more hydrogen peroxide down into the generation bottle to capture your gas that it will travel through. Again, you'll know when you have gas coming through because you'll see little bubbles that start to form from your hook. What's going to happen is that gas is going to go into our test tube and it's going to build pressure inside the test tube that's going to push the water out into the beaker. And what we'll end up having are 3 test tubes filled with oxygen gas. When I have all 3 test tubes filled with oxygen gas, I'm going to take my pie pan with the candle and wooden splints. I'll light the candle and I'll take the wooden splint and light that aflame. When it catches on fire, I'm going to blow it out and I'm going to expose the burning stent that's glowing to the test tube. If I do this correctly, what I should see is the flame relight itself in the presence of oxygen, because oxygen is flammable. So we'll see how well you do today setting up the lab and following the instructions provided in creating your oxygen gas and relighting your glowing stent.